an important section in second order homogeneous ordinary differential equation, which is known as Euler-Cauchy equation. Euler-Cauchy equation, a very important section. Now, what do you mean by an Euler-Cauchy equation? Before that, what is the general form of a second order homogeneous linear differential equation with constant coefficients? A second order linear differential equation with constant coefficients, this general form is y2 dash plus ay dash plus by is equal to 0. Then which is the characteristic equation or auxiliary equation? Auxiliary equation is lambda square plus a lambda plus b is equal to 0. And if lambda square plus a lambda plus b is equal to 0 is the characteristic equation, then we get the characteristic roots. If there exist distinct characteristic roots lambda 1 and lambda 2, then y is equal to e raised to lambda 1x, y2 is equal to e raised to lambda 2x form a basis of solution. ഇനി അതുപോലെ തന്നെ ഡബിൾ റൂട്ട് ആണെങ്കിലും കോംപ്ലക്സ് റൂട്ട് ആണെങ്കിലും അതുപോലെ വാല്യൂസ് ഉണ്ടാവും. അതാണ് എ ഹോമോജീനിയസ് സെക്കൻഡ് ഓർഡർ ഹോമോജീനിയസ് ലീനിയർ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ വിത്ത് കോൺസ്റ്റന്റ് കോഎഫിഷ്യൻറ്റ്സ്. In the same way, an Euler-Cauchy equation, what is the property of an Euler-Cauchy equation, or which is the general form of an Euler-Cauchy equation? And a second order differential equation of this form: x square into y2 dash plus axy dash plus by is equal to 0. Then y2 dash in the term, y dash in the term, y in the term. Shannon, what is the coefficient of y2 dash? X square. X square into y2 dash plus y dash in the coefficient x all over the function ax 3x no 4x no 5x അങ്ങനെ ax y dash plus y യുടെ coefficient എന്താണ്? ഒരു constant ആണ്. That means the coefficient of y is a constant. Coefficient of y dash is a function of x. And y2 dash a function of x square. Function of x square അതായത് ടൈം ഓഫ് x square. എന്നാൽ എങ്ങനെ വരണം? ഇങ്ങനെ തന്നെ വരിക. ഇങ്ങനെ x square into y2 dash plus axy dash plus by is equal to 0, where a and b are constants, is known as an Euler-Cauchy equation. An Euler-Cauchy equation എന്ന് പറയുന്നത് ചുരുക്കി ഇങ്ങനെ എഴുതും ECE, Euler-Cauchy equation. For example, I did x square into y2 dash plus axy dash 2xy dash minus by plus by minus 3y is equal to 0. That means this equation is in this form. What is the value of a? A is equal to 2. Axy dash. What is the value of b? B is equal to minus 3. Okay? Then what about this equation? 3x square y2 dash plus 6xy dash plus 15y is equal to 0. ഇത് Euler-Cauchy equation ആണ്. Euler-Cauchy equation ആണെങ്കിൽ y2 ഡാഷിന്റെ കോഎഫിഷ്യന്റ് x സ്ക്വയർ ആയിരിക്കണം. എന്നാൽ അങ്ങനെ x സ്ക്വയർ ആക്കാൻ നമുക്ക് ഇതിനെ ഈ 3 കൊണ്ട് അങ്ങ് ഡിവൈഡ് ചെയ്യാം. 3 കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ x സ്ക്വയർ y2 ഡാഷ്. ഇതാ 6 നെ 3 കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ 2xy ഡാഷ് axy ഡാഷ്. ഇതിനെ 3 കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ plus 5y is equal to 0. Now this is also an Euler-Cauchy equation. Then what about this one? y2 dash plus 1 by x into y dash plus 10 by x square into y is equal to 0. അത് Euler-Cauchy equation ആണ്. Euler-Cauchy equation ആണെങ്കിൽ എപ്പോഴും ഈ പ്രോപ്പർട്ടി ഉണ്ടാവണം. y ഡാഷിന്റെ കോഎഫിഷ്യന്റ് x വരണം. x ഉള്ള ഒരു ഫംഗ്ഷൻ 2x എന്നോ 3x എന്നോ ax ആയിരിക്കണം. What is coefficient of y2 dash? The coefficient of y2 dash is x square ആയിരിക്കണം. Here the coefficient of y2 dash എത്രയാണ്? 1 ആണ്. പക്ഷേ ഇത് നമുക്ക് എന്താക്കാം? x square ആക്കാം. അന്നേരം മൾട്ടിപ്ലൈ ചെയ്യും. മൾട്ടിപ്ലൈ ചെയ്താൽ എന്ത് വരും? x സ്ക്വയർ കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്താൽ x സ്ക്വയർ y2 ഡാഷ് പ്ലസ് x സ്ക്വയർ മൾട്ടിപ്ലൈ ഒരു x ക്യാൻസൽ ചെയ്യും. ബാക്കി എന്ത് വരും? xy ഡാഷ് x സ്ക്വയർ ക്യാൻസൽ ചെയ്യും പ്ലസ് 10y is equal to 0 into x സ്ക്വയർ. അന്നേരം അതിനെ നമുക്ക് ഏത് ഫോമിലേക്ക് മാറ്റാം? ഈ പറയുന്ന ഫോമിലേക്ക് മാറ്റാം. ദാറ്റ് ഈസ് x സ്ക്വയർ y2 ഡാഷ് പ്ലസ് xy ഡാഷ് പ്ലസ് 10y is equal to 0. പക്ഷെ അങ്ങനെ ചോദിക്കുക എല്ലാത്തിനെയും മാറ്റാൻ പറ്റില്ല. എല്ലാത്തിനും ഇതുപോലെ ചെയ്യാൻ പറ്റില്ല. X square in the y2 dash in the coefficient x square. Similarly, the coefficient of y dash in the x x all the time. Hence, the coefficient of y is a constant. I will form the x square y2 dash plus ax y dash plus by is equal to 0. We will Euler Cauchy equation examples. Ini second order linear differential equation with the constant coefficients. My solution and that assume e raised to lambda x is a solution. And the e raised to lambda x solution is a characteristic equation that solve the characteristic roots. Here we assume that y is equal to x raised to m be a solution of the given solution of 1. X raised to y is equal to x raised to m. That means y of x, y is equal to y of x is the solution of result of 1 or the Cauchy's equation. That is, if y is equal to x raised to m is a solution, then we will y2 dash and y dash and value of the equation satisfy solution. This satisfies the y solution. And then what is y is equal to x raised to m be a solution of 1. Then what is y dash? X raised to m into derivative. X raised to m into derivative m into x raised to m minus 1. Like x raised to n derivative n x raised to n minus 1. Here m x raised to m minus 1. What is y2 dash? Y2 dash is equal to differentiate y dash again with respect to x. That is m into. This will differentiate m minus 1 x raised to m minus 2. That is y dash is equal to m x raised to m minus 1. y2 dash is equal to m into m minus 1 x raised to m minus 2. Y dash y2 dash is substitute here. And substitute here is 0 value y value in the solution. Then the given differential equation becomes x square into y2 dash m minus 1 x raised to m minus 2 plus ax y dash, what is y dash? M x raised to m minus 1 plus b y is equal to x raised to m is equal to 0. Solution is value 0. Okay? That is, this is equal to m into m minus 1. This is x square into x raised to m minus 2. A raised to m, a raised to n, a raised to m plus n. That is 2 plus m minus 2, 2 cancel back into x raised to m. That is m into m minus 1. This is multiply the x raised to m plus a m. This x raised to m minus 1 in x1 multiply the x means x raised to 1. M minus 1 plus 1, like a raised to m, a raised to n, a raised to m plus n. That is x raised to m minus 1 plus 1 means x raised to m. A m x raised to m plus b x raised to m is equal to 0. If y is equal to x raised to m be the solution of this equation, then we have this property. M minus 1 x raised to m plus a m x raised to m plus b x raised to m is equal to 0. Then which is the common factor? X raised to m. X raised to m outside, that is x raised to m into m minus 1. Sorry, m into m. This multiply the m square. And m square, that is m square. Minus m, a minus m and coefficient x raised to m coefficient. We did the either under either m, either minus m, either a minus m, and then the m outside plus a minus 1 into a minus m outside a minus 1 into m, that's x raised to m plus b is equal to 0. That is x raised to m m square plus a minus 1 into m plus b is equal to 0. Then y is equal to x raised to m and solution, a non-zero solution. That means x raised to m is not equal to 0. Non-zero solution either. Other than 0. That is why x raised to m not equal to 0. And being a solution, a non-zero solution is not equal to 0. Either the x raised to m not equal to 0. Then back in term, that is we have m square plus a minus 1 into m plus b is equal to 0. And then yes, m square plus a minus 1 into m plus b is equal to 0. I will in the m x raised to m and the differential equation solution. That is the characteristic equation or auxiliary equation. നമുക്ക് ആദ്യത്തെ കേസിനകത്ത് ഏതായിരുന്നു ഓർമ്മയുണ്ടോ? വിത്ത് കോൺസ്റ്റന്റ് കോഎഫിഷ്യന്റിനകത്ത് ഏതായിരിക്കുന്നതാണ്? ലാംഡ സ്ക്വയർ പ്ലസ് എ ലാംഡ പ്ലസ് ബി ഈസ് ഈക്വൽസ് ടു. ഹിയർ ദ ഓക്സിലറി ഇക്വേഷൻ ഓർ ക്യാരക്ടറിസ്റ്റിക് ഇക്വേഷൻ ഈസ് എം സ്ക്വയർ പ്ലസ് എ മൈനസ് 1 ഇൻറ്റു എം പ്ലസ് ബി ഈസ് ഈക്വൽ ടു 0. അന്നേരം ആ എം ഉൾക്കൊള്ളുന്ന സെക്കൻഡ് ഡിഗ്രി ഇക്വേഷനാണ്. അത് നമുക്ക് സോൾവ് ചെയ്യാം. അത് സോൾവ് ചെയ്താൽ എമ്മിന് വാല്യൂസ് കിട്ടും, 2 വാല്യൂസ് കിട്ടും. ആ വാല്യൂസ് കൂടെ കൊടുക്കും. അന്നേരം ആ എക്സ് വൈ ഈസ് ഈക്വൽ ടു എക്സ് റേസ് ടു, അങ്ങനെ സോൾവ് ചെയ്തിട്ട് ഒരു വാല്യൂ 2 വന്നിരിക്കും. അന്നേരം എക്സ് സ്ക്വയർ ഇനി വേറൊരു വാല്യൂ 3, കാരണം എക്സ് സ്ക്വയർ ആയത് കാരണം 2 വാല്യൂസ് ഉണ്ടാവും. ഇഫ് ദേ ആർ ഡിസ്റ്റിങ്ക്ട് അന്നേരം 2, 3 വന്നിരിക്കും. If the values of m are 2 and 3, then y is equal to x square and y is equal to x cube are the solutions of it. Okay? Then is a differential equation, second order differential equation of this form, x square y2 dash plus ax y dash plus by is equal to 0, is known as Euler-Cauchy equation. y2 dash in the coefficient x square ആയിരിക്കണം, y dash in the coefficient x ഉള്ളൊരു ടേം ആയിരിക്കണം, y യുടെ coefficient ഒരു constant ആയിരിക്കണം. അന്നേരം x square y2 dash plus ax y dash plus by is equal to 0. Then what is the characteristic equation? Characteristic equation is m square plus a minus 1 into m plus b is equal to 0. In the earlier case, with the constant coefficient, what is the characteristic equation? Characteristic equation is lambda square plus a lambda plus b is equal to 0. ഇവിടെ Euler-Cauchy എക്സും കൂടെ വരുന്ന കേസിനകത്ത് കോഎഫിഷ്യന്റ് എക്സ് സ്ക്വയർ ഇൻറ്റു y2 ഡാഷ് എന്നാണ്. അന്നേരം Euler-Cauchy ഇക്വേഷൻ്റെ കേസിനകത്ത് ദ ക്യാരക്ടറിസ്റ്റിക് ഇക്വേഷൻ ഈസ് ലാംഡ സ്ക്വയർ അല്ല, പകരം എം സ്ക്വയർ പ്ലസ് എ മൈനസ് 1 ഇൻറ്റു എം പ്ലസ് ബി ഈസ് ഈക്വൽ ടു 0. If x square y2 dash plus ax y dash plus by is equal to 0 is the Euler-Cauchy equation, then the characteristic equation is m square plus a minus 1 into m plus b is equal to 0. If the equation is the second order homogeneous linear differential equation with the constant coefficients, that is x y2 dash plus a y dash plus by is equal to 0, then which is the characteristic equation? The characteristic equation is lambda square plus a lambda plus b is equal to 0. If the equation is an Euler-Cauchy equation in the form x square y2 dash plus ax y dash plus by is equal to 0, then the characteristic equation is m square plus a minus 1 into m plus b is equal to 0. For example, consider this equation: x square y2 dash plus 2x y dash minus 3y is equal to 0. What is the value of a? X square into y2 dash plus ax, that means a is equal to 2. What about b? b is equal to minus 3. And what is the characteristic equation? The characteristic equation or auxiliary equation is m square plus a minus 1. Here a is equal to 2, then 2 minus 1 means m, 1 into m, plus b minus 3 is equal to 0. That is m square plus m minus 3 is equal to 0. Okay? Similarly, what is the characteristic equation of this equation? Then dividing throughout by 3, we have the equation is x square y2 dash plus 6 divided by 3, 2x y dash plus 5y is equal to 0. What is a? A is equal to 2. Then the characteristic equation, what would be? B is equal to 15 by 3 is equal to 5. The characteristic equation is m square plus a minus 1, that is 2 minus 1 into m plus 5y is equal to 0. So again, then if x square y2 dash plus ax y dash plus by is equal to 0 is the Euler-Cauchy equation, then the characteristic equation is this one: m square plus a minus 1 into m plus b is equal to 0. A very important section. Neither the same here, not like one. What is the general form of Euler-Cauchy equation? The general form of Euler-Cauchy equation is x square y2 dash plus ax y dash plus by is equal to 0. And what is the characteristic equation or Euler equation? The characteristic equation is m square plus a minus 1 into m plus b is equal to 0. Then, if the characteristic equation have distinct roots, then what are the solutions? Similarly, if the characteristic equation have repeated roots and complex roots, then which are the basis of solutions? For that, we have seen that the characteristic equation or auxiliary equation of Euler-Cauchy's equation. Which is Euler-Cauchy's equation? X square by 2 dash plus axy dash plus by is equal to is given by x square plus a minus 1 into m plus b is equal to. Then the result in the first case is if the characteristic equation have distinct roots. The distinct roots m1 and m2. This equation two roots ഉണ്ട്. Assume that the roots are distinct and they are given by m1 and m2. Then which are the solutions? The solution will assume that y is equal to x raised to m1. Therefore, a basis of solution are y1 is equal to x raised to m1, y2 is equal to x raised to m2. If y1 and y2 are basis of solution, then which is the general solution? General solution is given by this one, c1 into y1 plus c2 y2, or c1 x raised to m1 plus c2 x raised to m2. Okay? The next we assume that this characteristic equation have double root. That root is repeated. If m is a double root or repeated root of the characteristic equation, m is double root of repeated root. If m is a double root or repeated root, then the basis of solution are given by y. Solutions are y1 is equal to x raised to m. Second one, y2 is equal to x raised to m into log x. M or repeated root angle basis of solution are y1 is equal to x raised to m and y2 is equal to x raised to m into log x. Aditha case with the constant coefficient of repeated root angle lambda is a repeated root, then e raised to lambda x. Aditha x e raised to lambda x. Distinct root angle e raised to m lambda 1 x e raised to lambda 2 x. This repeated root case e raised to lambda x, x e raised to lambda x. y1 is equal to x raised to m and y2 is equal to x raised to m into log x. Then next, the characteristic equation, the roots are complex conjugates. And then let m1 is equal to p plus iq. P real part, q imaginary part. And m2 is equal to that conjugate this p plus iq p minus iq. m2 is equal to p minus iq are complex conjugate roots. P plus iq, p minus iq. Then the basis of solutions are given by, then the basis of solution are y1 is equal to x raised to p real part into cos q log x. X raised to p into cos q log x. And y2 is equal to x raised to p into sin q log x. I think it's not with the constant coefficients e raised to px into cos qx. E raised to px and cos omega x. E raised to px into sin omega x. y1 is equal to x raised to p, where p is the real part, into cos q log x. y2 is equal to x raised to p into sin q log x. Then what is general solution? General solution is given by a y1 plus b y2. Or general general solution is cy1 plus c2 y2. This case general solution y1 is equal to x raised to m, y2 is equal to x raised to m into log x. Then c1 y1 plus c2 y2. That is x raised to m into c1 plus c2 log x. Okay? This general solution is given by y is equal to x raised to b into a cos q log x plus b sin q log x. That was c1 y1 plus c2 y2. And then the Euler-Cauchy's equation is a characteristic equation a square m square plus a minus 1 into m is plus b is equal to characteristic roots. This is repeated root angle. This distinct roots angle. This repeated root in the basis of solution. In p plus iq and p minus iq are complex conjugate roots. Then basis of solution are x raised to p, x raised to real part into cos q log x. Otherwise x raised to p sin q log x. y1 y2 basis c1 into y1 plus c2 into y2 general solution. A very important section. Because Euler Cauchy equation solve save not like that. Now consider an example for the Euler Cauchy equation. The method of solving an Euler Cauchy equation. Solve x square y2 dash plus xy dash minus y is equal to. That is, the given differential equation, a second order differential equation, which is in the form, the given differential equation is in the form x square y2 dash plus axy dash. That means where a is equal to 1 plus by is equal to 0, b is equal to minus 1. That means the given differential equation is in the form x square y2 dash plus axy dash plus by is equal to 0, where a is equal to ax where a is equal to 1. What is b? B is equal to minus 1. By equation the coefficients in the x which is the general form y2 dash plus a into y dash plus b into y is equal to 0, where all the coefficients are constants. But in this case, the coefficient of y2 dash is x square, and the coefficient of y dash is also includes the terms of x. The problem and the coefficients constants. Euler Cauchy method. Then a and b, what is the characteristic equation or auxiliary equation? Auxiliary equation is m square plus a minus 1 into m plus b is equal to 0. Auxiliary equation is m square plus a minus 1 into m plus b is equal to 0. That is m square plus a 1 minus 1 a minus 1 into m plus b is equal to 0. That is m square plus 1 minus 1 into m minus 1 is equal to 0. That is m square minus 1 is equal to 0. M square minus 1 is equal to 0 that is m square is equal to 1. That is m is equal to plus or minus 1 and root. Sorry, root or plus or minus 1. Plus or minus root 1. That is equal to minus 1 or plus 1. M square minus 1 we can factorize m square minus 1 square, which is in the form a plus b into a minus b. That is m plus 1 into a minus 1 is equal to 0. If m plus 1 is equal to 0, that means we have m is equal to 1 and m2 is equal to minus 1. If this term is equal to 0, that is m is equal to minus 1. If the second term m minus 1 is equal to 0, then we have m is equal to 1, or m1 is equal to 1 and m2 is equal to minus 1 are two distinct solutions or roots of the characteristic equation. That means m is equal to 1 and minus 1 are the two distinct characteristic roots of the given equation, given Euler Cauchy equation. If the roots are distinct, then what are the basis of solution? Basis of solution are given by y1 is equal to x raised to m1 and y2 is equal to x raised to m2. That is, y1 is equal to x raised to m1 means 1 and y2 is equal to x raised to minus 1. What is x raised to minus 1? 1 by x. That is, y1 is equal to x raised to m1 means x raised to 1 and y2 is equal to 1 by x are linearly independent solutions, or therefore a basis of solution. Then what is the general solution is? General solution is given by y is equal to c1 by 1 plus c2 by 2. That is c1x plus c2x raised to minus 1, or y is equal to c1x plus c2 by x is the general solution. That is the general solution of the given Euler Cauchy equation. This is a distinct roots example. This is a save it note like that. Repeated root and complex root examples we shall discuss in the next class. Save here.